This is Making Better Decisions. I'm your host, Ryan Sullivan. Decisions are where rubber meets the road for organizations. Each week, we'll be learning from people who are on the front lines of turning raw data into better outcomes for their organizations. This show is sponsored by Canopy Analytic, helping companies make better decisions using data. Hey, everybody. Welcome to another episode of the Making Better Decisions podcast. Today's guest got his bachelor's in mathematics and physics from UC Irvine, then went to the University of Michigan for a master's in mathematics and computer science. After that, he finished his PhD in neuroscience at the University of Minnesota. He's worked in the manufacturing, IT, and government industries. He previously worked for 3M, NOAA, and the U.S. Department of Justice. He was the chief data officer at the Air Force Space Command and then the U.S. Space Force. He also taught neuroscience and statistics at North Dakota State University. He is the author of Next Generation Data Management. Please welcome Deputy Chief Data Officer for TRMC at KBR, Mark Brady. Welcome to the show, Mark.
Hey, thanks, Ryan.
Super excited to have you. I want to jump right in. What is one thing you wish more people knew about using data to make better decisions?
I wish that more people realize what the current state of the art was in data science.
Tell me more about the current state of the art.
Well, we all know from the history of science that before there was chemistry, there was alchemy. And so, by way of analogy, I would say that currently we are in an alchemy stage for most organizations. So, what I mean by that, I can explain with a few examples. There's a lot to go into on that, but just a few examples. So one of the primary models that is used in most organizations, you can see it in their data strategies very often, is the data lifecycle. And it turns out that we don't actually manage data in a data lifecycle, nor should we manage in a lifecycle. And you see all these different versions of it out there. If you just do a web search on data lifecycle, you'll find scores of these things. And the reason why there's so many versions is because they're trying to find something that actually works. And that reminds me of the Ptolemaic model of the solar system, where they found that the data didn't exactly match up with what they were observing. So then they put epicycles on the orbits, and that was closer, but not quite right. So they put epicycles in the epicycles and so forth. So that's kind of the data life cycle. And then there's practices that aren't really best practices. Like the original idea for the data warehouse involved separating your transactional data from your analytical data, which suggests that you can't analyze your transactional data. So, which is rather strange, I think. And it violates a true best practice, which is that you need to integrate all of your data, which is interrelated. So, so that was a bad idea, really. But fortunately, we're moving away from that to more of a general idea of what a data warehouse is, just a centralized place to put your data. And then the third point that I'll make on the current state of affairs is language. One example there would be the data lake. So the idea of the data lake started out as a place where you would put your data that you were ingesting before you had a plan for what you're going to do with it. Just dump it into this data lake. People quickly found out that this was a bad idea. So you would think, okay, this term is going to go away with the practice, but it didn't. So people who weren't quite sure of what data science was supposed to be or whatever, they're meeting in conferences and whatever, and they want to sound like they know what they're talking about. So they all started using this term data lake, and it stuck, and you see it all over the place now. But if you ask 10 people, you get 10 different definitions. So, why is that important? Well, can you imagine doing physics or something or mathematics, and well, we're not quite sure what our terms mean. We're all using different terms. Obviously, it'd be a total failure. And so it is with language and current data science. For example, one of the impacts would be, say, an organization decides that they're going to build or they're going to buy a data lake and they don't know what it is. So they invest millions of dollars in this thing. They don't know what it is that they're trying to do. And at the end, they don't know what they created. So it has real implications.
This is an exceptionally refreshing take. Um, when you first kind of made the point, okay, well, we're at the early stages of really getting our hands around data. I'm sure there were many people. I even had a little bit of the internal reaction like, whoa, wait a minute. Well, look at all this stuff. And it's been around for decades and, people are doing AI. There's all sorts of but when you gave a little bit more information, I can't help but agree that as far as the collective data wisdom out there of professionals who are practicing to say that we completely have our hands around it and we know how to handle these large quantities of data which are constantly changing. We know how to handle all the errors. We know how to connect all of it. We know how to go from a business just doing what the business does and make reasonable, predictions or guesses about the future and then change our behaviors, make better and different decisions based on that spend good money after bad, whether it's on something shiny or, with the best intentions, really going after it. The return on investment within data has to be really cautiously managed. And so I think a lot of people focus on, okay, let's like tighten up the use cases, much more specific, focus on we're trying to answer this question. Let's do minimum viable product, iterate. But from your answer, it struck me that you may have some thoughts on what guiding principles could possibly be that are not the industry norm. So, if I could press you a little bit, like if you had the keys to the kingdom, what changes would you make across the board to other organizations to help them make better use and not waste that money?
Yeah, sure. I'll definitely share that. Before I do, though, I'd like to explain a little bit about why it's surprising, right? So you had a reaction that, hey, this does relate to something that I know, but at the same time, it's kind of a surprise to hear that we're not super advanced. And
Mm,
the reason for that is that people aren't sure what data science is or supposed to be. Um, we get it confused a lot with analytics. So if you think of a workflow, the analytics is really at the end of all your data management uh, efforts. So you're creating that data, you're making it so that you can find it, you're making it so that you can understand it, you're making it so that it's well structured and it's well integrated and all that. Then you're ready to do your analysis. But I've seen organizations that define everything that they do as just analytics. And in terms of staffing, they run into issues with that too. So they'll hire a bunch of analysts, which are awesome. And I think that's actually the place career-wise where people should start to get into data science is to be an analyst. But an analyst is not the same thing as a data scientist. A data scientist knows how to do analytics, but they also know how to do everything that's upstream of that. So, in analytics is extremely advanced. You have statistics, which has been developed over hundreds of years. It's extremely mature. The idea of relational databases, those have been around since the 60s. Query languages, all that sort of stuff, visualization, very, very mature. So if a person thinks that that's data science, that's all of data science, then yeah, they would think, I thought it was mature. As far as AI is concerned, obviously AI runs on data. And so they're closely coupled, data management and AI. You get better AI if you have better data. Um, but AI is a separate discipline as well. So great strides being made there. So to get back to your other question about, well, what should we be doing?
mm,
The logical place, well, first of all, we need to be more precise. So the problem with what I was describing earlier, which I call first generation data management, is that there was a notion that if it's not accurate, well, it's going to be good enough. Just kind of throw it out there. We'll use imprecise terminology. We'll come up with a practice, and no one ever asks, well, is that actually a good practice? What's it based on? Oh, you're going to use a star schema for these databases or whatever. Like, okay, why? Um, so you need to be more rigorous. You need to have a rigorous engineering discipline, and the nature of data science, the practice of which is data management, really is a blend of something like mathematics because it's very highly dependent on logic and engineering. That's what it really is. So anyway, you need a good starting point, and going back and looking at the big picture before you just dive in and start doing things, you need to ask yourself, what is it that I want to do? And how is that connected to my data? And because, and this is going to sound strange, but we don't really care about data for its own sake. Data, there's a purpose to managing data and collecting data and using data. And so the model for that really is what I call the 5 strategic factors. So the thing that everyone wants to do is they want to win. Coming from a recent military environment, I think about winning, but whether you're in business or whatever you're doing, you're trying to win.
Hmm.
So you win by having a winning strategy. And there's a strategic universe, right? So what a strategist does is they take a look at all of the strategies that are available to them. And out of that, they pick the best winning strategy. The universe also has losing strategies. It has some winning strategies that are more expensive and don't give us good outcomes and so forth. So that's what a strategist does. But the data people, the true data scientists, they're not doing the strategizing. Okay, that's another job, very important. What they do is they actually manipulate that strategic universe. How can I change my strategic universe, my set of all available strategies? And you can do that with the 5 strategic factors. So what are the 5 things that completely describe or determine your strategic universe? One is what you have. It's your physical stuff, including people. The second one is what you know. And then for most organizations and individuals, you have competition. So what does the competition have? What does the competition know? And then there's the environment. So for military strategists, it could be a river or a mountain. It could be the weather. For other organizations, it could even be things like public opinion and so forth. So if you can manipulate those things, then you can change that universe. And 2 of them directly have something to do with data, right? What you know and what your competition knows. But then there's all sorts of interesting interactions between those things. For instance, do you know what you have? If you have millions of assets, where are they? What are they? What state are they in? Are they ready to be deployed and used? So forth. There is the interaction between what you know and what your competition has and what your competition knows. So that's your intelligence. And there's even an interaction between what you know and itself. So, do you know what you know? It sounds almost like a cliche, but actually, if we get to it, and we probably will, it turns out to be something very profound.
One of the things that I love about getting to have conversations, particularly strategic conversations with folks that have military background, is there is just like such clarity of thinking. I feel like the types of landscapes that the military thinks in and operates in require that level of clarity prior to taking action.
Yeah, there's a big penalty if you don't have that.
Indeed, yeah, so you find folks that have cycled out of the military and back into industry, they bring this kinda clarity of thinking, that is really interesting. I love those strategic factors that you broke down. And I do wanna dig into that, you know, the relationship between what you know and itself. But before we do that, I'm interested to ask you about something as it relates to rigor. So, not as in depth. I didn't take it as far. I did no graduate study, but my undergrad was in math, and so I have at least a foundational understanding of that. And with that comes an understanding of rigor. One of the things that I find very different about that world, which I obviously there's quite a bit of applied mathematics, but I would argue that the most rigor happens in academic settings with mathematics. There's a bit of a trade-off. I remember I was presenting research as an undergrad at, like, the big math meeting that happens every year, and so I'm walking outside the San Diego Convention Center, and it's like it was a very strange situation, right? Like, so mathematicians, right, had just taken over the city of San Diego. Like, everybody that you talk to on a street corner was, like, a PhD or something weird. So I get talking to one guy, and I see his badge, and he tells me that he has a PhD in tic-tac-toe.
Okay. I thought that was a solved problem.
Yeah. Well, so of course, right, like, getting a PhD, sometimes we have to find, niche problems. So he was like, "Well, I'm actually a game theorist. I study lots of different games, but when I was doing my PhD, we did, n by n dimensional and, many layers and yada yada." I was like, "All right, well, what'd you find out?" And he said, "Well, so long as you move first and don't make any mistakes, you should always win or draw." I was like, "All right, well, cool. That's interesting."
Mhm,
Um, but taking that academic rigor thinking
mhm.
and combining it with what I know about the real world to address a point that you made, there is a little bit of a trade-off between getting tangible results and, like, feeling like we're winning and actually winning right now in the real world, and the ability to produce extremely rigorous structure, process, ideas, what have you. And one of the things that I have found from, being a consultant in this space for around a decade is many times we may have an idea of where we want to go and what structures we want to develop, whether that's, the forbidden data swamp or,
Mhm.
like a warehouse, or sometimes it's, hey, we want to like invest in this over the next 5 years. We want to use data to drastically improve the performance of our sales team or whatever. Even if we have a really strong goal, many times you get into those initiatives and it 1 year in, if the sales team is not selling double, they're like, ah, well, this, hatcheted, right? The budget for this
Mhm.
product, it's not working. So I think there's this balance between having the right amount of rigor and then also having tangible results that show the progress of whatever initiative you're on. And I'm curious to know what your thoughts are on balancing the two of those so that these initiatives continue getting the rope to continue.
Yeah, so getting results when you're faced with a tough, rigorous challenge where you're trying to make things rigorous, but it just doesn't fit with your real life goal. I think compromising on that is a last resort in the following sense.
Mm,
What I encourage people to do before doing that is to look for the win-win. How can I get my cake and eat it too? Very often that's lying there. You just have to be a little bit clever to find it. So I'll give you an example. I'm going to get just slightly technical here, um, but hopefully folks can follow me. So there's all sorts of different types of databases out there, two general categories: relational databases and something called NoSQL. And one of the arguments for the NoSQL, which is supposedly newer, but actually isn't, and we can talk about that later if you want to as well, to understand the difference between old and new is really important in data science. So people would say, "Oh, I have to break things up into all these different tables in order to have this rigorous, accurate database. Maybe I can deal with the thing being inaccurate and gain some convenience of having everything in one table." Well, it turns out that you can have your cake and eat it too. You can make it completely accurate by doing what we call normalizing, breaking it into a lot of different tables in a very specific way.
Mhm.
And then for your convenience, you combine all that into what they call a view, which is a single table, which combines data from your accurate database. And because it's derived from that, it's also accurate, but it's very convenient. So I'll give you another example too of where something which seemed like it'd be impossible turned out to be possible. And actually, this is one of my favorite things to do is to actually do things that people think are impossible. In one of the organizations that I work for, I was helping the parent organization to develop their data program and data strategy. And as part of that, it was decided that every database would have a data management plan. Where you're going to store the data, are you doing quality control, et cetera, et cetera. So I was asked to brief a science board on this. These were the leaders of the organization, and so I did that, and and they said, "Well, we have over 2,000 databases." And they did a few back of the napkin calculations, and they said this would take many man years to do this, so we're just not going to comply. So I said, "Okay, well, you know what? I think there's a way that we can just press a button and it'll just spew out 2,000 data management plans." Of course, they all laughed because they thought, well, obviously he's joking, right? You're not going to do that. So then I went to our programmers and I explained to them how they might be able to do this. And in 3 weeks, they had it done. Pressed a button and 2,000 data management plans spewed out. And the reason that was possible was because of our preemptive work. What we had done, we collected something called metadata. And I noticed that the metadata was very similar to the content of what was required in the data management plans. So all we need to do is to query that out of the database and reformulate those into 2,000 PDFs.
Yeah, I've actually many times as like a part of an initiative, we'll get asks for, some flavor of something similar. People are like, yeah, oh well, you're gonna have to, pay people in writing. And it's like, no, you literally when you built this, if you, built it right and have the right requirements, right? Well, we have all that information.
Mhm.
And it's just about programmatically accessing it. One of the other things that I was exceptionally happy to hear, right? Like when you first started off, I was like, oh man, like I wonder which of the things that I'm doing or recommending Mark might have input on. Like, how much am I going to need to learn and change? So there are definitely a couple new ideas that I've gotten. To thank you for those so far. But I was really happy to hear when your example of win-win
Mhm.
was imbuing a certain portion of the business logic and the structure into dynamic views, which I don't think is too technical. But for anybody who's listening, who's like, I don't know what that is, you have all sorts of queries and all these tools, whether you're in Power BI or writing on a SQL database or whatever. Um, it looks a lot like a table, but instead of actually being stored on a disk, it's just a saved query. So when you access that table, it just runs a query instead of reading it off a disk. And we actually just did this. So for one of our clients, what they were looking to do was to build a data warehouse. So they had, taken data from a lot of operational stores and had gotten it into one place. And I actually, if we get the chance, I'd love to circle back to talking about lakes and having them not turn into swamps and stuff like that. But the two big things that they needed were they needed the systems to be able to integrate. So the data from those systems needed to be able to talk to one another. We also wanted to get it on a platform that was properly allocated for the data size, right? So instead of having my little wimpy laptop computer, it's like, well, we want like a big beefy server that has everything that's able to crank through it. And there was a lot of talk about, oh, okay, well, what are we going to do? Like, what's the management plan? How are we going to run all the jobs to get all these tables built? And I was like, we're just going to make views and we're just going to leave it at rest, and all the business logic will be there. And all the reporting, instead of having business logic and all the reporting, we're going to put the business logic in the views. So when it changes, the 15 reports that are pointed at it, I don't have to go in and change that logic 15 times in each one of those reports. We're just going to change it right here and it will flow right through and the numbers will just update. And this ended up being a massive time saver and success, and has allowed folks at that team to, instead of focus on putting as much of their time into maintenance, maintenance never goes away and it shouldn't. But it has allowed them to focus on handling new requests, delivering new reporting, and hopefully making better decisions a bit faster. I had put a pin in something earlier that I am really excited to get to. So when we were talking about the 5 strategic factors, you mentioned, one of them, which is what you know, kind of having a relationship to itself and understanding that relationship as being valuable. I wonder if you could say more about that.
Yeah. So there are some historical cases uh, that show that knowing and not knowing is an incomplete description of what it means to know. In other words, there's more than just those two states. And how do we know that? How did we learn that? And there are a few different examples out there that people are familiar with, but 9/11 is probably the most famous example.
Mm,
And 9/11 is largely considered to be a surprise attack. However, it was not a surprise attack. People may have heard of the flight lessons in Minnesota, something like that. We had some inkling that something was going on. Actually, the amount of information that we had was enormous. And I gave a talk one time, and a guy came up to me afterwards, and I had mentioned some of what we knew, and that he had briefed or been involved in a briefing for the National Security Advisor. And of course, he was very disheartened because the whole prediction was just cast aside as, nah, that's not going to happen. So we had information from other intelligence agencies. Uh, we had information from major players in Afghanistan. We had multiple briefings to the president. We had information that was in multiple security agency um, data sets. They weren't sharing it. And we even had the name of the operation. It was called the Big Wedding. We knew it was going to involve aircraft. We knew all that. So basically, we knew there was going to be an attack. We knew what kind of attack it was going to be. We knew there was going to be a 9/11. So the fact that we didn't do anything, though, indicates that we didn't know. And those two facts together tell us that our idea of a binary know, don't know must be flawed. It's like in science generally, when you have a contradiction like that, when you have a paradox, you realize, oh, okay, now it's time to move forward with a new theory. We have to have a new theory to fix this. So the fix is to realize that there's really 4 levels of knowing, not 2. The first level of knowing, level 1, is where we were prior to 9/11. That is, you have the data, and that's all you have. But level 2 is you know what data you have. So thinking of that organization with the 2,000 databases, and they have over 6,000 databases now,
wow.
there's no one person that you could ask, hey, I need information X. Where's it going to be among those databases, especially since the databases themselves could have dozens of tables in them. Just think about or you could have information on the same fact or topic scattered across those databases, right? So knowing what information you have, that gets you to level 2. And that's knowing what you know. That's that reciprocal relationship between knowing and itself, knowing what you know.
Mm,
Level 3 is understanding your data. So suppose those people who are interested in predicting a terrorist attack, they not only knew where to look for the data, but then they also knew what it meant, possibly by integrating the data. Right. So data in the context of other data is where you get your insights. Individual bits of data are really not that insightful. So if you'd put all this information together, you would say, hey, we have to find these terrorists and do something right now. But actually they were trying to put that plan together the day of the attack, and that's too late. And there's ways to solve that also. And then the level 4 is understanding the data in the context of other data.
Mm.
So it's the highest level. So if we were at level 4, 9/11 would not have happened. So we think of data science and data management like this little tweak, like maybe we can get another 10% benefit out of our data if we hire these people to massage it and so forth. But actually, it has an enormous impact, a historic impact in some cases.
Yeah. Super poignant example, obviously. Um, One of the things as you were talking that came to mind is the degree to which humans are involved um, in at least the last three of those four levels. Um, Obviously, over the course of technological advancement, there are inroads being made with automating or simplifying kind of the three steps between those four levels. But one of the things that we've had the opportunity to talk about here on the podcast and also that we've gotten to do in some of our client work is talking about how much the human element affects an organization's ability to be able to continue moving across those four levels through different, whether it's subject matter, particular questions, or whatever the case may be. Um, I think that there are, you know, bias. There are like all sorts of psychological biases that happen. There are internal politics. There is, an understanding of the tools, like whatever the framework is that the information is being presented in. Like I could build someone a fantastic Power BI report, but if they don't really know how to work Power BI, they're not going to be able to get in there and understand things relative to those contexts. Um, Combining your example with that idea, it kind of makes me think of the similarities between a given business setting and the unfortunate example of 9/11. I think that it would be a silly statement to say, okay, well, the entire intelligence community doesn't ever stop attacks, right? Like there are all sorts of situations that would be another story if they hadn't been effectively stopped. But then there's this one horrific one that was not. So comparing that to a business setting, how do we manage the human element of each of those steps? And importantly, the finiteness of the human element within business. We can scale computers to do incredible things. But as far as, like, focusing on, okay, well, there are, taking it out of, the military and intelligence example and putting it into a business example, well, there are, 250 possible questions that we could be asking and answering right now, and we have a very finite amount of human talent that is going to be allocated towards addressing those 250 problems. How do we manage that finiteness and hopefully allocate those things right so that nothing gets missed, like your example?
There's a lot to unpack there. So the alternative to first generation data management is what I call next generation data management. And it actually, in addition to the models that I talked about earlier, the five factors and the four levels, there's, where do you start your actual practice? What are the methods that you're going to use to be at level 4? That's where organizations want to be to really win. First thing, you don't start with the data, actually. You start with the users, the data users. So that's the people you're talking about there. You model them. So one model where people are actively engaged and where you need to support them is called the active user model. The active user model describes a user, a collection of users that first looks for the data, then tries to understand the data, then wants to integrate the data and access the data, and then ultimately they're going to either write software which ingests that data, or they're going to do analysis, which is what this podcast is all about. So that's one. But then you mentioned the limitations of human capability. And for that, in particular situations, there's something called the notified user model. And this would be one that would be very useful in a 9/11 type situation and a lot of other situations. And in that case, what you do is you determine, okay, what are the events that I want to predict? Then I determine what kind of data I need and then what combination is going to predict those. And that's the sort of thing, it needs to be done in advance, right? So you think about
Mhm.
9/11, it's too late to do it on the day of the attack, right? It involves planning. You also need to think about who is going to be the actor and what are they going to do. And once you figured all that out, then you build a system which will do all that automatically and will then notify a person and then make sure that, okay, let's confirm that they actually were available. They're not on vacation or something, and they actually completed the task, which would address whatever this event is. So that's the notified user model. And then there's other user models. The most complicated one is the command and control user model, which would be used in military or maybe disaster response circumstances and so forth. The other way to think about limitations on human capability is that we have to realize that the world is getting more technological all the time, and yet we can't just retrain people to go from some other career to being in high tech because only about 4% of the population has the aptitude. So you're just not going to retrain those other 96%. So you have a limitation there. But with the help of AI, you can increase productivity and you can also produce better quality. So one thing that is largely missing and is part of this whole first generation approach is documentation. So we're always building black box data systems,
Mm.
and you hear the word stovepipe thrown around a lot, or silos. All my systems are all separate, and well, you can't easily integrate them because you don't even know what's in them. Somebody created it and then they just moved on. They left no record of how the thing works. And we have large language models that can help with documentation. They could, for instance, take a look at a piece of code and explain what that algorithm is that's in it. And in terms of programming, we have AI generated programming. Obviously, you still have to have people in the loop. It's more of a place to start than a finished product. And then there's testing, which is very important. Right now, with DevSecOps and Agile, which I think are largely being misused because there's no engineering. It's more like seat of a pants thing, and people measure their success by number of releases. Well, I had 10 releases today, and well, how many bugs were in it? Nobody no was what was the user interface like? Did it follow basic rules of design, or no, it didn't, but by God, we put out 10 releases. So, that's related to testing, and we
Yeah.
can automate a lot of that too. So if you look at human testers, it takes them a long time to exercise a piece of software and go through all the different states. It could have millions or billions of different states, right? And so there's errors, bugs lurking in there. You'll never find them. but a software exercising other software, testing software, can take you through orders of magnitude more states. Now,
Mm,
where you would need an advance in AI, and we'll probably get there, is to recognize which of those states are error states and which are not. So we're in kind of an absurd situation right now where we're kind of post-literate over thousands of years. The human race has become more and more literate, and now we spend all of our reading and writing time on social media with mostly nonsensical, meaningless stuff, and we're not documenting our technology as we build it. It's just a black box, and it's very buggy. So, you know, part of this is what I call the first singularity, our situation that we're in. So, everyone is familiar with the AI singularity, where we lose control of our technology. Before we even get to AI, we've already lost control of our technology. And you know that because when you go to the service desk and you say, such and such isn't working, I'm trying to get this done, and it's just freezing up or it's doing something crazy. They don't actually address the problem or find the problem. That they will rely on a workaround because they don't actually know what the problem is. I mean, the bug may get overwritten in the next release, but we don't know. Where we look at our data systems almost like biological organisms, and we don't
mm.
completely understand biology. So we're looking from the outside, like, how does this thing work? It evolved, but the crazy thing about the first singularity is we created these things and we don't even understand what we created, but there is a way to understand it. And then the final point regarding the human factor is if you talk to people in the field, CTOs and so forth, and you ask them, okay, what is your number one issue? They'll actually say that it's cultural. So there's a lot of reasons, and this is related to the non documentation also, that people will want to hoard data and data system architectures because there's an idea that there's job security. So we need to turn that on its head, and we need to have people's performance evaluations based on teamwork and how much data are you sharing? Okay, you just created some technology. Did you share the intellectual property behind that? If you didn't, then you're not creating any value. Maybe you shouldn't have a job.
There's no way that I can follow that up. That was I put together a really good question, but man, you just
Uh-huh.
slam dunked that.
Mhm.
There's one thing that I wanna make sure that we get to
Mhm.
before we start wrapping up, and that is the idea of data lakes.
Yeah.
I couldn't agree more. I actually I've been in the, you know, this rodeo for a little while. I haven't heard data swamp yet. That's pretty funny. Um, when I mentioned that example of an organization where we were using views and like some concept of lake, and I agree with you, like let's be clear around definitions. When I say lake, I mean, okay, we have many operational systems. Each of them is a cup of data. We're going to take them and we're going to dump that cup into one place so it can communicate and have that place be a place that's allocated to do the next step really effectively.
Mhm.
Do you think the problem with lakes is one of definition and terminology? Is the idea of a data lake fundamentally flawed? And if so, what should replace it?
Well, the original idea of a data lake was well defined, but it was a bad idea. And hence you get the data swamp. And that's because structure in data is really enabling. So if you have no plan and it's all disorganized, then it's hard to automate, for instance. And so this is where we have to be careful with AI is because, and I love AI, I'm a former AI researcher, but the idea that you just have a hodgepodge of disorganization and you sick AI on it is not a good idea because AI is an attempt to make computation more like human thought and to err as human. So it's going to make a lot of errors the sort of way that humans make errors, right? Like a person, they could do a calculation 100 times, say longhand division or something like that. and they could do it right 99 times, and then on the 100th time, they'll do it wrong, right? So there are certain forms of computation analysis which are foolproof. So, like if you're playing chess and you see, okay, in 4 moves, I'm going to checkmate my opponent, I'm not going to go and say, okay, well, yeah, I want to try something more clever. Let's think about something else.
Yeah.
I want to checkmate that guy, right? I'm just going to go for it. So we don't want to. That's a little bit of a side. Like that's why we don't want to use AI. So that's what the data lake was, and so it was good that it was well defined, but it was bad because it involved no planning, no structure.
Mm,
Structure is really important because you can automate data in its processing. If it has structure, you can do all kinds of foolproof analyses and so forth. So that's why you want to have the structure when you can get it. And there's different types of structure, and almost all data is structured. So the idea of unstructured data is really um, not very accurate as well. But the new definition really doesn't exist
mm,
because you just came up with a definition of a data lake. But say you're in a planning meeting with a bunch of other people in a company, and everyone else has a different definition of what it is. So it's okay to then start the meeting by saying, okay, this is what we mean by a data lake, and then proceeding from there. Understanding that when you get to the next meeting or a different context, then you got to start over because you can't assume that everybody knows what it means. So I think it's the best practice not to even talk about data lakes because you don't, one thing, you don't need it. There's, there's other terminology which exists, which is precise,
mm,
like a database, a data repository, metadata repository. Uh, the more modern or recent definition of a data warehouse, which is just a centralized place to put your data, which is actually a good idea because if we're going to be integrating that data and getting your insights of data in the context of other data, you want to put as much data together as you possibly can.
mhm. I think I fully get you now that it really just comes down to the buzzwordiness of some of these terms and making sure that when we decide what we're gonna do, we've actually decided what we're gonna do and why, and that that's a good idea as opposed to, "We're gonna get a data warehouse." It's like, "Okay, cool. What does that mean and why are we doing it?"
Yeah. Data mesh is another one. And so I was in a
Oh,
meeting
yeah,
one
don't
time, and it was an all day meeting, and people were throwing around some of the buzzwords. And so we go out in the hallway in a break, and somebody takes me aside and goes, hey, I feel kind of stupid, but what is a data mesh? I said, don't feel bad. Don't feel stupid at all. It doesn't mean anything.
Oh, Mark, you are a powerhouse of knowledge and experience on this stuff. This was an hour that just absolutely melted away for me. I feel like I could talk to you for another 3 hours. So maybe we'll have to have you back.
Yeah. It seems like we've only been talking for 15 minutes.
I know, I know. I also really appreciated the tangibility of some of the frameworks and some of the
Hmm.
stuff like that. I'm assuming a lot of that's laid out in your book. Is that right?
Hmm. It is. Yeah. Next generation data management.
Yeah, I will be making sure to take a copy of that and learn a little bit from that and hopefully help some
Hmm.
people pick up some of those ideas because I found it rock solid. So, outside of writing books and be learning all this stuff and being involved in everything that you're involved in, tell us a little bit about yourself.
Well, I find it refreshing to spend some time in the physical world because we're all kind of like in the matrix in our pods, in virtual reality a great deal of the time. So I like to get out there. I do some big game hunting, some marksmanship, like to grow things and do things like that.
I actually have I the plants here were not always a part of the podcast backdrop. I
Mhm.
will be honest, I'm really good at killing plants. I'm not very good at growing them and keeping them, but I'm trying. It's an
Mhm.
exercise in it engaging in maintenance work.
Yeah, yeah, it makes you feel good if you can make it work.
That's right. Yeah, there's a lot of lessons in growing plants. Um, Mark, if there's usually I say if there's anything anybody liked, but I think if there isn't anything that anybody liked in this conversation, they're crazy or they're not really a good fit for this podcast. This was chock full.
Mhm.
So when people have things that they're
Mhm.
interested in, they want to learn a little bit more. We already mentioned the book. Where else can folks reach out and connect with you?
Well, I'm very interested in hearing from people and hearing their own stories because if we can uh, put together our global experience, it's going to be a lot richer. Although I have, pretty rich layers of experience myself, but I'm always interested in hearing your stories as well. And if you are interested in learning more about next generation data management, you can find me on LinkedIn.
Awesome. Mark, I have already said it, but this was an absolutely incredible episode. Thank you so much for taking the time to do this and sharing all of your experience and also all of the time, effort, and energy that went into accruing and building that experience. You were so tangible, so concise, and so direct. Huge value for me. I assume huge value for the listeners. Thank you so much.
It's been a lot of fun, Ryan.
I also want to thank all the listeners, especially if you've made it this far. It felt like 5 minutes to me, but we're running on like 50 plus minutes in. So if you've listened to all this, thank you so much for being a listener. If you got something out of it, please make sure to tell a friend, all the normal stuff. Give us a like or review, hopefully a good one. This has been another exciting episode of the Making Better Decisions podcast. Thanks so much for listening. That's a wrap for today's episode of Making Better Decisions. For show notes and more, visit makingbetterdecisions.live. A special thank you to our sponsor, Canopy Analytic. Canopy Analytic is a boutique consultancy focused on business intelligence and data engineering. They help companies make better decisions using data. For more information, visit canopyanalytic.com. There's a better way. Let's find it together and make better decisions. Thank you so much for listening. We'll catch you next week. Peace.